Hello everyone, welcome in a new video. In this video we are going to understand about FCFS scheduling algorithm. FCFS means first come first serve scheduling algorithm. In this video we are going to solve some questions related to this scheduling algorithm and understanding this algorithm in detail. Okay, so first of all, what is FCFS means? FCFS scheduling algorithm is basically in this algorithm a process basically decide to get the CPU. Means what does this means? That this is CPU. Okay, so we have CPU and this is memory. We have operating system and so many processes. Okay, now what going to happen is in FCFS algorithm, how the process is basically get the CPU. In FCFS, the process basically go to the CPU in an order. In an order means those process who come first in a ready queue will get the CPU first. Let's say that P1 is a process who come first, P2 is a process who come second, and P3 is a process who come at third. So first of all, the P1 is the process who get the CPU first, and then P2 is a process who get a CPU second, and P3 is a process who get a CPU third. Okay, so this is what first comes first serve do. So what is the scheduling criteria here? Here whatever process has a minimum arrival time. What does this mean? Means whose process come first get a CPU. What does the alternate of this thing? That whosoever is a smallest arrival time will get the CPU first. For example, what is arrival time? Bus time, TET. We discuss these words. We are going to use these words in this video. So if you know about this, then well and good. If you not, then you have to watch the previous videos for that. Okay, so let's say we have a process P1, P2 and P3. So the arrival time of P1 is 0, P2 is 1 and P3 is 2. Okay, so arrival time means the process who come in a ready queue. So P1 is a process who come first in a ready queue because his arrival time is 0. So whosoever process has a minimum arrival time, that process come first in a ready queue. And what the FCFS says, the first process in a ready queue will get a CPU first. Okay, so what is the scheduling criteria here? Whatever process has what or whichever process have minimum arrival time will get the CPU first. Whosoever process is basically have a minimum arrival time will get the CPU first. And what happen if the arrival time is same? For example, the arrival time of P1 process is 0, arrival time of P2 process is also 0, and arrival time of P3 process is also 0. So now which process will basically get a CPU? So in this case, when there is a tie between an arrival times, so how we select a process? We select process by seeing their ID, by seeing their process ID. Here you can see that in this question is the question is look like P1, P2, P3. So P1, P2, P3. So we will select the process in this order, in an increasing order. So P1, if the arrival time is same, then we see this condition. Okay, so when arrival time is same 0, 0, 0, then P1 is a process who get a CPU first, and then P2 is a process who get a CPU, and P3 is a process who will get a CPU at number 3. Why we choose this sequence? Because of this process ID P1, P2, P3, P1, P2, P3. We have to select in increasing order when there is a tie between an arrival time. Okay, so if there is a tie, if tie occur between the processes, then what we have to do? We have to select minimum process ID first. We have to select minimum process ID first. So P1 is 1 is minimum, and then 2 and then 3. So this is what this line says, that you have to select the minimum process ID first. Okay, So you understand about FCFS concept. Okay, now there is one more thing, that which kind of algorithm it is. We discussed that the algorithm is of two types, non-preemptive and preemptive. So non-preemptive means when operating system are not that much sufficient, or you can say that process if running in an CPU, so it can leave CPU only when process is completed. Okay, operating system cannot remove that process. Operating system does not have that power to remove the process. This is what a non-preemptive processes. Okay, and preemptive means that if a process running in a CPU and there is a high priority process comes, so what operating system do? Operating system snatch CPU from the running process and put that process in a ready queue. This is what is happen in a preemptive case, and FCFS is basically a non-preemptive algorithm. FCFS is a non-preemptive algorithm. It means nobody can snatch the CPU if the process is running. Okay, so this is what the basic information about the FCFS. Now we are moving to solve the questions. Okay, so question will look like process. We have three process in this question, P1, P2 and P3. We have an arrival time. Let's say the arrival time is 0, 0, 0, and we have a burst time. Let's say the burst time is 27, 5, 5. So this is what a burst time is look like. Okay, so let's say 25. Okay, so this is what a process, and this is what AT arrival time and BT is the burst time. So if you know about that, well and good. Not, then you have to watch the previous video. Now what we have to do is, in this question we have to find the average of turnaround time and the average of waiting time. Okay, so the question is looking like this. In a gate exam point of view, or in your college exam point of view, the question will ask you about the average turnaround time and average waiting time. Okay, so for that average turnaround time and waiting time, what we have to find? First of all, we have to find the completion time, and then turnaround time and the waiting time. So how we gonna find this? How we are basically finding these solution of this means how we find CT, TAT and WT. Let's see this thing. Now we are going to find these things. So what is the completion time? How we find that? So for that we have to make a Gantt chart. To finding the completion time, what we have to do is we have to make a Gantt chart. What is a Gantt chart? Gantt chart basically define that which process will get a CPU, in what sequence basically the process will get a CPU. Okay, so and remember one thing, that Gantt chart is started from 0. Gantt chart never start from a negative or never start from greater than 0. It always start from 0. Okay, so after that what we have to do is, so at 0 we have to see that how many processes basically there. So at a 0 means this is what arrival time. This is what arrival time, because we are now arrived the process to get a CPU. Okay, so arrival time is 0. Every process arrival time is 0. So we can choose any process in between these three. So which process will get a CPU first? So what I told you in FCFS, when there is a tie between the arrival time, what we have to do is we have to select process in a increasing order, or process in a minimum ID. So here you can see that 1 is lowest, then 2, then 3. So we have to select the process in this sequence. So P1 will select first, then P2 and then P3. So P1 to P3 is a process we have at 0 arrival time, but we choose P1 because of its minimum ID, or we have to select in an increasing order, and 1 is minimum, so we are selecting P1. Okay, and what is it? Burst time. Burst time is 25, so I have to write 25 here. Now why I write 25? Why I not write 5? Why I not divide this 25 into some parts? Because it's a non-preemptive process. So when a process is in a running state, then no one can snatch the CPU from that process. That process will execute fully. That process leave the CPU when its work is done, and or when it's terminate. Okay, so 25, and then after that 25 we have two processes, P2 and P3. Definitely P2 and P3. So now which process will get a CPU? P2 is a process who get a CPU because of the sequence. And what is its burst time? Burst time is 5. Now you cannot write 5, you have to add this thing. Okay, add this 5 in this completion time of P1. This is what a completion time of P1, because at after 25 P2 is start. So for P2 25 is a arrival. 25 is basically arrival time, and it's not an arrival time because P2 is arrive at 0 as well. So for P1, 25 is basically a completion time. 25 is what? A completion time for P2. Okay, now P2. What is its burst time? Burst time is 5. Add 5. Now it becomes 30. So 30 is what? 30 is the completion time of P2. After that, only one process left, which is P3. So P3 acquires CPU. Now, what is its burst time? Burst time is 5. So we have to add 5 and 30. So it becomes 35. Okay. So now we find the completion time. I hope you know that how you are understand that how we make a Gantt chart. Now we have to write a completion time of these processes. For P1, completion time is 25. For P2, completion time is 30. For P3, the completion time is 35. Now turnaround time. So if you watched the previous video, then well and good. If not, then you have to know that what is the turnaround time. Turnaround time basically completion time minus the arrival time. Completion time minus arrival time. So what is the completion time for P1? 25. What is the arrival time? 0. So we have to subtract this thing. Okay. So 25 minus 0, 25. 30 minus 0, 35. 35 minus 0, 35. Simple. Waiting time. Waiting time is what? TAT minus burst time. Waiting time is what? Turnaround time minus burst time. So TAT minus B, 25 minus 25 for the P1, it becomes 0. 35 minus 5, it become, okay, so it's 30, not 35. Okay, so it's 30. 30 minus 5, so it's become 25. Okay, 35 minus 5, it's become 30. So now we have to find the average turnaround time. So what is the average? How we calculate the average? The sum of TAT divided by the number of processes, we will get an average. So 25, 30 and 35 divided by the number of processes. We have 3 processes, so divided by 3. So now the answer is 5, 5, 0, 6, 7, 8 and 9. 90 divided by 3 means 30 is what? Average TAT. 30 is what? Average turnaround time for this processes. Now what is an average waiting time? How much on an average, how much time a process have to wait? And this is what an average means. Average waiting time means. An average TAT means how much time it's the process basically spent in a CPU. Simple. Now average waiting time, 0 plus 25 plus 30, 25 plus 30 divided by 3, so it's become 5, 3, 4, 5, 55 divided by 3, so 3, 1 is 3, 25, 3, 8 are 24, 24, 25, 3, 3 is 9. So 18.3 is what? Average waiting time. 18.3 is the average waiting time. So I hope you understand that how we're gonna find the average TAT and average waiting time. What does this means? This average TAT means how much time the process is spent in a CPU. Average waiting time means how much process have to wait to get a CPU. Simple. So this is how the numerical of FCFS have to solve. Now we see one more numerical related to this. Now we have a processes. Now we take more than one processes. So P1, P2, P3, P4, P5 and P6. Okay, and we have an arrival time as well, not in a sequence, 0, 1, 2, 3, 4 and 5. And we have a burst time. Burst time is like 5, 1, 2, 4, 5, 3. Now what we have to do is we have to find the same thing, average turnaround time and average of waiting time. Okay, so for that what we have to do is we have to find completion time, turnaround time and the waiting time. So how we find that? With the help of Gantt chart. First of all, what we have to do is we have to create a Gantt chart. Okay, so the Gantt chart always start from 0. So now 0 arrival time, how many processes are there at 0, 80? Only one process, P1. So if there is only one process, so I have to put that process, I have to give CPU to that process. So what is it? Burst time. Burst time is 5. So now arrival time has become 5. So how many processes are there now? We can select from P2 to P6 any process from between P2 and P6. We can select any of them process, So which process we are going to select first? Whose arrival time is minimum, because here there is no tie between an arrival time, so whosoever has a minimum arrival time will get a CPU first. So P2 is a process, P2 is the next process to get a CPU. What is its burst time? Burst time is 1, so add 1 and 5, it's become 6. After P2 we have to select P3. Why? Because of minimum arrival time among these 4 processes, P3, P4, P5 and P6. So P3 is the one who we select. The burst time is 2, so we have to add 2, so 6 plus 2 is become 8. After that P4 is a process, burst time is 4, so 8 and 4 become 12. After that P5, burst time is 5, it becomes 17. And after that P6 is the only process left, burst time is 3. You add that burst time in this completion time of P5, you will get 20. So now we get an completion time for all the processes. For the P1 completion time is 5, P2 completion time is 6, P3 it's 8, P4 12, P5 17 and P6 it become 20. Now TAT, how we find TAT? Completion time minus arrival time, so it becomes 0, and 6 minus 1 become 5, 8 minus 2 is 6, 12 minus 3 is 9, 17 minus 4 is 13 and 20 minus 5 is 15. So this is what turnaround time. Now we have to calculate the waiting time. So waiting time is what? TAT minus burst time, turnaround time minus burst time. So turnaround, okay, so it's become 5 not 0, because TAT what? Completion time minus arrival time, so 5 minus 0 we will get 5. Okay, now waiting time is what? TAT minus burst time, so 5 minus 5 0, 5 minus 1 4, 5 and 6 minus 2 is become 4, 9 minus 4 become 5, 13 minus 5 8 and 15 minus 3 is 12. So we will find out the TAT and waiting time. Now what we have to do is we have to add all these and divide it by the number of processes. So for the average turnaround time, it's 5 plus 5 plus 6 plus 9 plus 13 plus 15 divided by the number of processes. So in this case there are 6 processes, so divided by 6. Okay, so the sum of these number is 5 and this become 53 divided by 6. So 53 divided by 6 become 8.8. It become 8.8. So the average TAT is what? 8.8. Average TAT of these processes 8.8. Average turnaround time is 8.8. Means on an average the process is spent 8.8 unit of time in a combination of in a CPU, basically in a CPU. Now after that, average waiting time. So waiting time is like 4 for 8 and 8 16 and 12 plus 5, so it become 33. So 33 divided by 6, so 33 divided by 6 you will get 5.5. So 5.5 is what? The average waiting time. So what does that means? What does that means? On an average, process have to wait 5.5 unit of time to execute. Okay, so this is how the question have to solve. So now we are solving one more question and we wrap up the video. So the question is like, now we are doing something different question. P1, P2, P3, P4, P5 and P6. Now and after that the arrival time is like 5, 8, 6, 3, 1 and 7, and burst time is like 4, 2, 3, 1, 2, 7. 4, 2, 3, 1, 2, 7. Completion time, turnaround time and the waiting time, what you have to find out. So now what you have to do is you have to pause the video and solve this question by yourself and comment down the average TAT and average waiting time. I'm not going to solve this. You solve this and comment down your answer. I'm simply finding out the values of these things. So okay, so I hope you do that thing. Now I'm going to solve this. So Gantt chart. Now this is a very important question to understand the concept of FCFS very clearly. Why I say this? Because here you can see that there is no arrival time starting from a 0, but what we know that the Gantt chart is always arrive from 0. So now what we can do, if there is no process at 0, so we can take an example like that. You are going to play a cricket, or you are going to play any game. Okay, so let's say cricket, and what you have to do now, your team is going to bat. So now what situation is like, you are basically in your home and your friends call you and say that we are going to bat and you are my opener, so you have to come fast. Okay, so but what, the game is start. So if a game is start, if your player is not in a field, is your player is gonna bat? If your player is not in a field, then how can your player will bat? So it's like not possible situation. Yes, a similar situation is occur in this case as well. At arrival time 0, we have no processes. Then how we can write the processes between these given processes? So definitely we are not gonna write anything. So from 0 to 1, the CPU become idle. Okay, you so many students, what they do, they write P5 and they run this P5 process. So this is what a wrong thing. The process is not in a ready queue, then how you can execute that process? Okay, P5 process come in a ready queue at 1 arrival time. Then at 1 you can give CPU to P5. But if there is no process in a ready queue, then how you can give CPU to process? Similar situation like this. If your player is not in a ground, your player is at home, then how that player can bat? So it's like impossible situation. Okay, this situation never occur. So this is what the situation is here as well. If there is no process in a ready queue, then CPU become idle. So at 1, now P5 can get a CPU at 1, because only one process is there, P5, so P5 will get a CPU. What is it? Bus time is 2, so we have to add 2 in 1, so it become 3. So at 3 arrival time, so which process we have only one process, P4, so P4 will get a CPU, and the bus time of P4 is 1, so we have to add 1, so it become 4. Okay, at 4 we have no process right now. Okay, so 5, the process which basically left is 5, P1, P3 and P6. So we have only, okay, so we have and P2. So we have 4 processes left. But here you can see that at 4 arrival time we have no processes. So what now, CPU become idle till 4 to 5, because there is no process in a ready queue. Then how CPU will work? If there is no process, then CPU will not work, CPU become idle. So at 4 to 5 CPU become idle. At 5 we have one process, P1, so P1 acquire the CPU and the bus time is 4, so at 4 with 5 will become 9. At 9, now all the 3 processes are available, P2, P3 and P6. So whose process will have a minimum arrival time will get a CPU. So P2 is a maximum arrival time, P3 is a minimum arrival time between P2, P3 and P6. So P3 will get a CPU and the bus time of P3 is 3. So 9 and 3 become 12. After that 2 process left, P2 and P6. So P6 have a smallest bus time. So P6 will get a CPU. The bus time is 7. So it become 19. And one process P2 is left. Bus time is 20. So it become 20. And the completion time of P2 become 21. Okay. Now what we have to do is we have to find this thing. Means what we have to do is we have to find the average turnaround time and average of waiting time. Now completion time is what of P1? P1 is completion time of P1 is 9, P2 is 21, P3 is 12, P4 is 4, P5 is 3 and P6 is 19. Now we have to find the average turnaround time, which is what? Completion time minus the arrival time. So 9 minus 5 it become 4, and 21 minus 8 become 13, 12 minus 6 6, 4 minus 3 1 and 3 minus 1 2, 19 minus 7 19 minus 7, so it become 12. Okay, Now waiting time is what? TAT minus the burst time, so 4 minus 4 0, 13 minus 2 11, 6 minus 3 3, 1 minus 1 0, and 2 minus 2 0, 12 minus 7 become 5. So now you can easily find the average TAT and average waiting time. What you have to do is you have to sum up all these things and divide it by the number of processes, which is 6 in this question. So yes, this is all about first come first serve. Okay, so I hope you understand this first come first serve scheduling algorithm and what is its conditions, what type of process it is, how we're gonna solve this question. Okay, so this is all about the FCFS in this video. There is a one problem with this first come first serve problem. What is that problem? For that you have to click on the next, and you have to see the next video, which is a Convoy effect. Okay, which is a small video, you can go and check it out. This is all about in this video. Thank you for watching this video. Like the video and subscribe my channel.